Physics and Director of the Center for Quantum Frontiers of Research and Technology at National Cheng Kung University. Dr. Chen's presentation is titled Quantum Entanglement, Bell's Inequality, and Madhyamaka Karika. Please join me in welcoming Dr. Chen to the stage.
So thank you very much for the introduction. Welcome to Q4, this Center of National Cheng Kung University. So you see, I gave the similar presentation in Taipei last week. So I'm not sure the English translation is correct or not. Okay. Tainan is actually the very first city of Taiwan. And 400 years ago, the Dutch people came, so they left this historical remain called An Ping Fort. So it doesn't work, right? I cannot. Okay, now. So you see the name of our center is kind of long, right? Center for Quantum Frontiers of Research and Technology. So why we have such a long name? Because if you look at the acronym, there's a Q Fort, right? So we have an An Ping Fort 400 years ago. Now in this university, we have a Quantum Fort in this year. So now we are one of the national center of the quantum technology, belongs to the Minister of Education. So like any research center, we have some research goals, like cutting edge research, technological innovation, and premier global research hub. And before lunchtime, we will have chance to look at this the core facility. There's you see this big refrigerator in the ground floor, and inside we have a quantum chip. This is a quantum computer. We have a chance to look at this. Okay. So before the talk, in the beginning, I would like to ask you a question. Is the moon out there? Okay. So you may ask, what a stupid question this, right? But I tell you that for a quantum physicist, it's not that simple. The answer is not that simple. Okay. So I show you this. This is a paper in Nature Physics and 2010. It shows that in a micro-sized superconducting loop, and the scientists discovered that the law of quantum mechanics apply in this device. So therefore, the Nature Physics give a cartoon presentation of this result. You see in the figure that if you can look, if a light hit the moon is there. If you do not look at the moon is not there. Okay. So all this strange quantum physics phenomena come from this. Okay. Wave or particle, right? Now we all know that for a tiny particle, so we have this particle and wave duality, like electron of atom. It has both the wave or particle nature, right? So, and imagine this is the red ball is an electron incident from the left. Okay, in the middle is a gray wall. From a classical thinking, so if you think this is a ball, right? When this particle meet this wall, it will be rebound, right? But in the quantum mechanics way, because it's a wave nature, if the incident energy within a certain energy level, certain amount of energy, it can penetrate through the wall. So this is quantum tunneling. Okay. Then, and scientists sometimes it's a bit boring. They think about this. If a larger molecule like this, C60, so of course it's much larger than this a single electron or single atom. For such a larger particle, does the wave nature still exist? Okay, that's the question. So now people still perform this kind of experiment in the laboratory. So now every time the experimentalist send a C60 molecule from the left-hand side, so when the particle arrives in the middle, there are two slits. Okay, so you may think that okay, the ball, the molecule will go through the upper slit, right, and reach the right screen and hit the position. Then you made the marker there, right? Then you do the second experiment. So now this time, the C60 molecule may go through, for example, the lower slit, right? Then hit at the screen at another position, right? So you continue this kind of experiment, say 1,000,000 times, right? So on the right-hand side of the screen, you have many collection, right? So you just count how many times the molecule hit certain position, right? Then that means you histogram all the data. You get this kind of, you see, the wave-like result, the experimental result. You may say, oh, even for this larger particle, you see this wave nature, right? But wait, the story is not end. So as I said, the scientists sometimes very boring, right? So they would like to know that whenever this molecule passing through the slit, which slit the molecule pass through, okay? So now the scientists place 2 cameras behind the 2 slits. So now remember, the camera is just to watch the molecule, but never touch the molecule, just watch, okay? Then redo this experiment 1,000,000 times again. So guess what? Then you find that the interference, this wave feature, disappear. Okay, you feel strange, right? I just watch it, I didn't touch it, but the wave nature disappear. So you don't believe, then you remove the camera again, then redo the experiment the 3rd time. So if you do not watch this, then the wave nature reappear again, okay? So this is very strange, right? So therefore, so the scientist, the quantum physicist has to admit that if you do not watch the molecule, so this C60 molecule pass through the 2 slits simultaneously. What does that mean simultaneously? Say, for example, you walk into this lecture room this morning, right? So maybe from the back door or front door, right? Then I'm telling you that you come into this lecture room simultaneously from the back door and the front door simultaneously, right? So it's impossible, right? But for this molecule, it happens, right? So for this kind of wave nature and probabilistic explanation, so Einstein does not like this very much. He said that I like to think the moon is there, even if I'm not looking at it. So in his belief, he believed this the realism, right? This material world is independent existence there. Okay. So now, for this kind of theme appear at 2 places at once, then to some extreme condition, you arrive this famous cat in the physics, the Schrödinger's cat, right? To be or not to be, that can be in the simultaneously in the dead and alive situation, right? So this kind of things that Einstein really don't like this, right? He once said that the God does not play dice, right? And Niels Bohr answered him that Einstein, stop telling God what to do, right? So there's a strong debate between these 2 great scientists, right? So now, until this 1935, Einstein and his 2 colleagues proposed a severe challenge to this quantum mechanics. From the modern language, now it's a quantum entanglement, or you can call this a EPR, paradox, okay? So what is the entanglement, okay? So imagine now you have 2 particles, A and B. So in the beginning, in the center, you let these 2 particles entangle together. Then you send 1 particle into the left-hand side of the universe. Then the other particle is sent to the right-hand side of the universe. So on the left-hand side, say, if you measure particle A, and you get the result, say, spin up, right? Then according to the law of quantum mechanics, the wave function collapse. Then on the right-hand side, the particle B would be in a down state immediately, okay? Faster than the speed of light, right? So then Einstein at that time, sorry, not yet, okay. Can you go back, right? So Einstein at that time said that, oh, this is so strange because it's like a spooky action at a distance, right? Because at 1905, he already proposed this special theory of relativity, that any information cannot over the speed of light, but this entanglement is instantaneous, right? So therefore, he said that it must be the quantum mechanics is incomplete, right? Or violated the special theory of relativity, okay? So now until 1964, John Bell, another great physicist, proposed. He said, I have a solution to this, okay? So I have a way to resolve the debate, okay? So he said that, okay, let us assume two assumptions, okay? Locality and the realism. What is locality? Locality means that because these two particles are already very far away, right? You measure on the left-hand side particle, too far away. There's no way to influence the other particle, right? That's locality. And realism means that I don't believe there's a superposition something, right? It's bullshit, okay? Even if I don't look at this, the particle, it's already in this spin up or spin down state. There's no such thing of realism. So therefore, according to these two assumptions, you can arrive at this kind of inequality. This measurement has to be bounded by the value of 2. So guess what? So the experimental result all shows that using entangled photon all shows the violate this inequality, okay? So until 2015, 3 papers always, he say, close the debate between this Einstein and the Bohr, right? And this is the picture of this John Bell. And he should receive the Nobel Prize, I think. Unfortunately, he passed away too early. Okay. So it's because this violation of this Bell's inequality, so 2 years ago, the Nobel Prize was awarded to the Alan Aspect, John Clauser, and Anton Zeilinger, okay, for their contribution in this field. So you may ask, why does this relate to this Buddhism, right? So my personal answer is that we have to look at the suffering in the Buddhism, okay? So this is a photo. I think in 2011, I followed this with this Tzu Chi brother and sister. We went to the Tohoku area. There's a big earthquake there, say. So I come with the Tzu Chi brothers and sister to deliver this consolation money. I think the very first day we arrived very early in the morning. Okay, I think 6 a.m. in the morning. So we thought we were already very early, right? But when we arrived there, already people waiting there for us. And some people told us that some elder people, they arrived at the place 4 a.m. in the morning. So when we heard of this, we feel so touched. Not because we are proud to give this money, it's because we realize that these people, they really need this money, okay? So at that moment, so I think I vowed to myself, I said that today I want to be a Bodhisattva, okay, or learn to be a Bodhisattva, okay? I need to do all my best to help these people, to comfort these people. So if there's an equipment to measure the happiness of my mind, I think the happiness of my mind on that day is very high, okay? So that is a suffering in the world. It's a very big, tremendous disaster, okay? But in addition to this, we have this spiritual suffering in everybody in our mind, right? Nowadays in university, that many young students have this kind of spiritual problem, okay? So this is the Master Zheng Yan and her master, Master Yin Shun. He's a great scholar, Buddhist scholar, okay? If you read his book, he often said that the root of suffering actually comes from the wrong perception of fact in the heart. So we have this self, I, right, exists independently, okay? We have a mental grasping everything, right? Existing everywhere, okay? We have a self, we have I there, okay? But if you look at this, the text of this Nagarjuna, especially this Madhyamaka Karika. Okay, so this book discusses this emptiness, right? And that is no self-nature, right? And often you see this Nagarjuna use this negative argument in this book, right? So one of the representative verses in this chapter on dependent origination, I think the English translation is not very accurate, and Chinese translation is better. It said, 如诸法自性不在于缘中，以无自性故，他性亦复无. There's a negative argument here, but if you look at the English translation, there's no such a negative argument, right? And anyway, the logical flaw of this, this emptiness is that if you assume the self-nature exists, then you will find that it violates the cause and condition. But it violates. So therefore, you have to give up this assumption. That means no self-nature exists, right? There's a logical flaw in this Nagarjuna's textbook. Okay. So if you come back to look at space inequality, it's similar, right? You assume local realism exists. But you see, in the past 30, 40 years, the experimental result show you the violation, right? So therefore, you have to give up this assumption on realism, right? So you compare these two things, right? The chapter on dependent origination, you have assumed self-nature independently exists. Then you violate the cause and condition. So you have to give up the emptiness, right? Then Bayes' inequality, there's a realism exists. It violates inequality. Then you have to give up the realism, right? So we often, in the Buddhist text, we often speak of this two truths, right? In the conventional level, right, this word is independent exists, right? But you investigate into the deeper level, then the Buddha tells you that this ultimate truth is there's nothing there, right? Then you can compare this with the physics. We have a classical physics, Newton's law, right? Everything is deterministic, right? It's independent exists. But you investigate into the microscopic level. Quantum physics is a realism not there, right? No realism, right? It's very similar to this. So I think the philosophy from quantum entanglement, my feeling is that, okay, I will cite the quotation from the Niels Bohr, right? He once said that everything we call real is made of things that cannot be regarded as real, right? From the research of quantum entanglement tell us this, right? So I once asked His Holiness that can study quantum physics help with inner peace, okay? So he answered that, like this. He answered that his daily practice is on this meditate on emptiness and altruism. Okay, his daily practice. And he said this appearance are infallible dependent arising, right? Then emptiness is free of assertion. Okay, he said that if these two things you are thinking is still separate, you are not reaching the real intent of Buddha. So when you see that, when you have such an experience and reach this type of experience that these two things are simultaneous and concurrent, then you really reach that really deep level. So he said that at that level, there's no basis for objectification. Okay. Then the last one is the most important. Then he said that quantum thinking can help with this. Okay, I like this. Okay, in the last few minutes, I would like to mention a theory that discovered in 1980s. That is no cloning theory. That in the quantum information community, that we often talk about this. We will encode this information in a qubit. Okay, the qubit is a quantum bit. Later we will see we have a quantum chip with a quantum bit, right? So in this quantum bit, we can encode our information, alpha and beta, in the qubit, right? And the quantum physics said that if you do not know the information and alpha and beta, then you cannot copy it. So this is very strange because for a paper like this, right? If you close your eyes for classical information, You just put this piece of paper into a copy machine. You close your eye and push a button, right? You copy that paper, right? You copy another information. But in quantum mechanics, you cannot do this, right? The information, if you do not know, you cannot copy this, okay? So, but although you cannot copy it, you can teleport it. You can transfer this information from one place to another place, okay? Just like the science fiction, Star Trek. So this has been proved in, I think it's in 1993. It doesn't work again, okay? This theory has been proved in 1993 by 6 scientists in IBM, okay? And information can be teleported. So this is an experiment in Vienna, okay? I think it's also done by Andong Zeilinger. They can teleport the information, the unknown information, from the riverside to another riverside. And, so in mainland China, so 8 years ago, they launched a satellite, quantum satellite, okay? They call this Mo-Zihao, okay? So now they can experimentally demonstrate that the information, this unknown information, can teleport from the Earth to satellite and come back to the Earth, okay? So this is unknown information. So I'm a physicist, so today we talk about this consciousness, right? So I cannot help to think about that if this consciousness is somehow related to this quantum information. So according to the Buddhism, right? So when people get dying, right? So the consciousness start to melt, right? Then to the subtle level, you have subtle mind, right? You have subtle mind. Then if the subtle mind leave your body, then you are dead, right? So I cannot help to think of this. If this subtle mind is related to the quantum information, right? Because there's some evidence show that some child can remember his previous life information, right? So this information teleport to the next line, perhaps, right? So if this subtle mind is related to quantum information, right? Then I was thinking that maybe it should be compatible with the law of quantum mechanics. Because in the quantum information, the law is that say that the quantum information is conserved. It will not disappear. It can transfer to another place. It will not disappear. So maybe this kind of subtle mind is, related to this quantum information. I may be wrong, right? Maybe my daydream, I don't know. But this is something in my mind I was thinking about. Okay. So let's my talk today. So actually, this center is a quantum center, and every Friday, actually, in this room, we will, Tzu brother and sister, they will bring this the children from poor family come to this lecture room, and the university student will come here to teach them homework, right? So through this kind of teaching, and I think we are cultivated the compassion of this in a piece of this young student. So I often proud to say this is not just a quantum center; it's a little bit this compassion center here. Okay. So thank you very much for your attention.